According to the National Center for Biotechnology Information, 2,000 escalator-related injuries occur each year to children between the ages of 0 and 19. 6% of these injuries involved a stroller. Escalators are dangerous for users who wish to transport their children in strollers. According to our research, various experts determined that maneuvering strollers up an escalator is not only unsafe but a common source of injury among children. According to Columbus's Children Research Institute, approximately 26,000 children were hospitalized between 1990 and 2002 for escalator-related injuries. There are few to non-existing solutions to our problem statement. One patented idea that we found involves a modification of a stroller so that the armrest attached to the handrail belt of the escalator. Another idea involves a belt conveying apparatus having a flat top surface for comfort and minimum stress. Neither of these ideas offered a valuable solution to our problem. After extensive research, each of our group members were tasked with brainstorming and designing 3 possible solutions to our problem statement. We compared these 9 possible solutions in a design matrix where we evaluated the ease of use, feasibility, safety, and the ability to be multidirectional of each design on a scale of 1 to 5, where 5 was the best possible score. After much analysis, we decided on a final design. Our idea consisted of inserting a retractable leg at the back of the stroller to help level the device when it is on the stairs. Through the use of Inventor, a 3D printer, and various other materials, we will design a bracket that will attach to the back of the stroller and hold the retractable leg. We plan to test our prototype by following a step-by-step plan. First, we will design, print, and secure the 3D printed bracket to the stroller. Then, using a 3/4 inch PVC pipe and caps, we will construct a kickstand that will act as an equalizer. We will then 3D print and attach the pipe holder to the bracket and secure them using screws and bolts. We will begin testing it by placing the front wheels of the stroller on the second step of an escalator. Again, the bracket will be composed of a front and back that will be secured together by 2 screws. It will additionally have a stand holder attached to the outside that will allow for the stand to easily slide through it. Once on the escalator, the stroller will need to be leveled out by pulling the pin and dropping down the stand so that the height of the front and back wheels are equal. Next, the user will place the pin back through the PVC pipe as to secure the height. When getting off the escalator, the user will once again be required to pull the pin so that the kickstand may be retracted into its original position. During our evaluation, we conducted 2 tests. Our first test consisted of using a cardboard box that represented the height of 2 stairs of an escalator. During this test, we dropped down the stand and replaced the pin in one of the holes that would make the back wheels the same height as the front wheels. We found that this made the stroller very unstable. We determined that the back wheels needed to be slightly higher than the front wheels in order for the stroller to be stable. We then modified our prototype so that there were more holes in the PVC pipe so we could make the stand longer. Our second test was more successful than the first. The stroller remained easy to use, was more stable, and proved effective when testing it on real stairs during our second test. The concepts we covered during our project included that of science, technology, engineering, and math. The elements of science that we will have to consider for the design of our project include the selection and observation of the types of materials used when building our stroller and how they will interact with each other. Engineering aspects that we will need to consider in our design include the elements of mechanical, material, and health and engineering safety, which will give us an understanding of the industrial system, simple machines, and safety hazards, respectively. Math will be used primarily in our building aspect when determining the measurements of the materials and when calculating the amount of material needed and how the weight will impact the stroller. There will not be any form of computer technology used in our design. We will primarily be using simple machines to create a stroller that will stay level while on an escalator.